Namaskar. Hello guys, let's have discussions and questions. And this questions was once asked in this examination. In the test examinations, this question was asked. Let's understand the questions and let's find the solutions of these questions. First of all, I want to read what is asked in the questions, and later on we will be discussing what is being asked to find out. The position and velocity vectors of a particle changes from r1 to r2 and v1 to v2 respectively as time flows from t1 to t2. That means it is asked, you have at some moment, at some instant time t1, its velocity is v1 and its position is r1. And later on at an instant time t2, its velocity is v2 and its position coordinate is r2. And the time is flowing from t1 to t2. In the positive direction of flow of the time, its velocity changes from v1 to v2 as well as its position coordinate also changes from r1 to r2. Then the question is asked, if r as a function of time, velocity as a function of time, and accelerations also as a function of time, are the instantaneous positions, velocity and acceleration. R, V and A, these three are the symbols of position, velocity and accelerations during that time t1 to t2. For any time t lies between t1 and t2, for any time t between this interval t1 to t2, this R, V and A corresponds to its instantaneous position, velocity as well as its acceleration. Then we have to compute this integral. What will the integral, this integral from time t1 to t2? Look, this is an integration. And this integration is a vector integration because the integrand, this is called the integrand, and the variable is obviously a real variable, but the integrand is a vector. So keep in your mind when you're integrating, you have to always use the cross symbol. You have to use always the cross symbol and don't extend these two terms while performing mathematical computations. Different formulas when you put into these equations, always keep in mind that the order remains same. Any kind of mathematical changes in these two terms will be done subjected that this cross product will be noted and it will be fixed at its positions. That should not be changed. So let's do this one. So before doing this one, I will remind you some mathematical basic theorem, integral theorem that is known as bypass. It's just an extension of one component and scalar integrations. That was bypass, but it is vector. The rule will be same for both of us. So let's do this integral. To do this integral, I want to erase that part and then we will do the solutions. Okay. First of all, I will tell you that's the formula. I won't write down the formula and then we will start its workout. Okay. So the bypass is, the simple formula was, you have two functions. One is u and another is v. And this u and v are function of the same variable, suppose x, that is dx. So the bypass says, if you have, and the two function you have, so the two function, one functions you want to easily integrate. I mean, one of the u and v, you could integrate a functions easily. Suppose I could integrate b easily. And if I could integrate b easily, then I will take it as my second function. Second function will the function which I could easily integrate. Okay, by looking at the two expressions, I know or I will fix that this function could be easily integrated, and I will be taking this function as my second functions, and this function will be the first function. Then this integral will be first function u into integration of the second function, because I have told you this I could integrate easily, and that was my second function. So first function into integration of the second function, that is integrations of the second function. Okay, without any limit. Here you don't have any limit. Okay, so if suppose limit is from a to b, I mean x range of x, that's x ranges from a to b, and this limit will be put here from a to b. Then minus, then you have to do the integration. Here you have to do the integration and the integrand, and the integrand is nothing but this function's differentiations. This function's differentiation, that means du by dx into this functions already you have integrated these functions, then this integrated term will be here. This integrated term, I mean this function, okay, the integration of v dx, I mean the integration of v will be here, and then these two terms will be integrated with respect to x. So you can find, you could extend this method further. Okay, you could extend this method further, and these formulas will be very helpful in calculating these terms. But keeping in mind, you can extend these terms here. You can write these terms here, you can write these terms here. But in this case, you can't do that. You have to keep in mind, always R will be kept, any mathematical operations to be done with this R will be kept first. We just need to solve this one by this method, by parts method. So how to do? Let's see. We have two terms. One is the position coordinate as well as another one is the acceleration coordinate. The acceleration coordinate from its definition is the 2 times differentiations. 2 times differentiation of the position coordinate. The 2 times differentiation with respect to variable t, and the same variable is here in the integration. Then I could easily integrate these terms, so that means it's my second function. I'll take it's my second function, and this r will be my first function. So then this what will happen? First function r into integration of the second function. Keeping in mind that the cross symbol will be here. Integration of the second function, first integration will give me this quantity, that is dr by dt. That is dr by dt. Then what I have to do? I have to put the limit t1 to t2. Then minus derivative of this first function. I mean this was my first function, this was my second function. Derivative of this first function here will be dr by dt. The cross symbol will be here. Next, integration of the second functions. I mean this functions is integration will be here. From limit t1 to t2. Now, what I'm doing here? What I am doing here? Just look. This terms dr by dt cross with dr by dt. Then what I'm doing here? This terms is the cross product of the same vector. Is the cross product of same vector. Cross product of the same vector becomes 0. That means this terms becomes 0. This terms becomes 0. And when the integrand is 0, obviously the integration will be constant vector. Constant vector. And the constant vector which is independent of the variable t2 as well as t1, then the limit from t1 to t2 will be 0. Then this terms becomes 0 and we are having only these terms. And this terms will be r at t2 cross with this dr by dt is the instantaneous velocity. So the velocity at time t2 minus position coordinate at time t1 cross with the velocity at time T1. So this will be the solution of the question. Actually, the solution of the question is just in one line. Okay, but I have to explain the theorem. That's why it takes some time. And this question is solved. Thank you for watching this video.